Okay, question 1 wants us to write the contrapositive of the following statement. If two angles are complementary, then they add up to 90 degrees. Well, contrapositive simply switches your hypothesis with your conclusion, and then it negates both statements. So in other words, we're going to switch these two statements in our overall statement and then add knots to negate them. So in other words, it would look like this. If two angles do not add up to 90 degrees, then they are not complementary. Question 2. What is the slope of the line that is perpendicular to the graph of the equation negative 2x minus 8? So all we're concerned about is the slope that is perpendicular. Remember, perpendicular means that we have to have a negative reciprocal. So original slope is negative 2. So if I want to find the negative reciprocal of that, we're going to take this negative 2, put it over 1. We're going to flip the fraction over, so it becomes negative 1/2. And since it's negative reciprocal, we got to change the overall sign. So that was a negative, so it becomes a positive 1/2. Question 3. What is the slope of the line that is parallel to the graph of the equation y equals negative 2x minus 8? So in the equation, our slope is negative 2, and parallel lines have exactly the same slope. So therefore, our slope is going to be negative 2. Okay, for question 4 and 5, we're going to start off at point A, and it's located at 0. And then point C is located at 36. Point B is the midpoint, so halfway between A and C is 18. So that's our midpoint, B. And then D is the midpoint of segment BC. So halfway between 18 and 36 would be 27. So there's my diagram. Let's answer some questions. Okay, so B to D, how far is that? That's simply 9. And then AC minus BA. AC is 36 minus BA, which is 18. So 36 minus 18 is 18. Okay, questions 6 through 20. We're going to use this diagram right here, and to help us start off with, and to get us started with this diagram, it says that angle 10 is 85 degrees, angle 7 is 23, and angle 16 is 122 degrees. So let's take care of some of the obvious ones real fast. So since 10 is 85, so is 13. That's also 85 degrees. And that means that angle 1 is also 85 degrees. 8 is 85 degrees. And there's those. Moving forward, since 10 is 85 degrees, that means angle 9, which is supplementary, is going to be 95. Which then means that angle 2 is 95 degrees, and angle 14 is also 95 degrees. Okay, coming over here to this group. Angle 18 is 122. Angle 4 is 122. And that's what we got from that so far. And then to find 17 and 15, these are 180 minus 122. So that's going to be so that is going to be 58 degrees. That means 15 is also 58 degrees. And angle 5 is 55 degrees. 58 degrees. And angle 3 is also 58 degrees. Okay, so far so good. We got 3 more angles to go. Okay, so since this angle right here is So since these two angles would be congruent with the 122, I can say that angle 6 is 122 minus whatever 23 is subtracted from that. So in this case, it's going to be 99 degrees. So angle 6 is 99 degrees. Okay, 2 more angles to go. All right, so right here, this angle right here. To figure this one out, all 3 angles inside of any triangle is equal to 180. So, to find this angle, 180 minus whatever 85 plus 23 is. So in this case, it's going to be 72 degrees. So angle 11 is 72 degrees. Okay, one more angle left. This angle right here. Alright, so since this angle is 72 degrees, and this angle plus this angle is going to be the same as 95, so I can say that 95 minus 72 will generate the answer. So that means that my answer is going to be 23 degrees. Alright, so for this question, we're going to use this diagram and determine what these angle pair relationships are for 21 through 25. Okay, so for question 21 and 25, we have angle 1 and angle 5. Since one is on the outside of my parallel lines, or on my 2 lines, and the other one's on the inside, these are corresponding angles. Angle 2 and angle 7, since they're both on the outside of my 2 lines, and they are on opposite sides of the transversal, they are alternate exterior angles. Angle 4 and 6, they're both on the inside, and they're right next to each other, so they must be the same side or consecutive interior angles. Angle 4 and 5. Okay, this time one's on this side of the transversal line, the other one's on the other side. They're both between the 2 other lines, so these must be alternate interior angles. And finally, 4 and 8. One's right here, the other one's on the other. This looks kind of like the first question we answered on this group. Corresponding angles. We're going to write a linear equation that passes to the point 3, negative 8 has a slope of negative 2. This is where we use that formula, y minus y1 equal to slope times x minus x1. The slope is m. 3 is your x1, negative 8 is your y1. Plug these 3 numbers right in. The y and this x stay the same. You don't mess with those. So y minus negative 8 equal to the slope, negative 2, times x minus 3. Okay, so minus negative, that's the same thing as plus. Distribute my negative 2 across the parentheses. So negative 2 times x, negative 2 times negative 3. So y plus 8 is equal to negative 2x plus 6. Next I'm going to subtract my 8 from both sides of my equation. So this is going to give me y equal to negative 2x minus 2. Okay, question 27. We're going to calculate the distance between point negative 3, 7 and 5, 0. This is where we use the distance formula, the square root of x1 minus x2 squared plus y1 minus y2 also squared. This negative 3 will be your x1, 7 is your y1, 5 is x2, and 0 is x2. Excuse me, y2. Okay, plug these 4 numbers right into the formula. So negative 3 minus 5, that will be squared, plus 7 minus 0, also squared, and don't forget our square root symbol. Okay, and then as far as I care, you can just type that right into a graphing calculator and get your answer pretty quick. So for me, I get 10.63. I'm going to round it to the nearest hundredth spot, so that will be my answer. 28, we're going to calculate the midpoint between A, -3.7, and B, 5.0. We're going to use the midpoint formula, so x1 plus x2 over 2 for the x-coordinate, y1 plus y2 divided by 2 for the y-coordinate. Again, these are coordinates, so we're not going to combine these two numbers once we're finished. They will be one single digit. All right, so x1 is -3 plus 5 divided by 2, followed by 7 plus 0, also divided by 2. Okay, so -3 plus 5, that's going to be 2. 7 plus 0 is 7. And we want to reduce as much as we can. 2 divided by 2 is 1. And 7/2, well, we can just leave that as 7/2. Or if you write 3.5, that's okay too. Okay, for questions 29 through 31, we're going to use this diagram to help us answer these questions. So the first one, what is another name for DE? Well, since we're talking about lines, we can name it either, obviously, ED, or we can name it for any other letters on the line, so DF, FD, EF, or even FE. These are all applicable names, and it doesn't matter the order of the letters in this case. Question 30. Name a point that is collinear with point A. So any point that is on the same line as A. So as long as it's on the same line, we're okay. So in this case, we can have point E and point B. Either one of those will be acceptable. What is the intersection of plane K and line WY? So look at line WY, and then right here, it starts becoming a dotted line, then solid line. So that means that this right here is on the other side of my plane. So it looks like this line is penetrating through this plane at this point X. You know, this question also asks, what is the intersection? If you answer it is a point, that would be acceptable as well. It's kind of a vague question. But either way, both are acceptable answers. Question 32. Write at least 2 sentences describing the translation below. All right, so, well, it looks like my object is actually moving down and to the right. So that's somehow you mentioned that, so we can say it moves down, and we can be specific about that. So from B to the new B, it's going down 1, 2, 3, 4 units. So we'll mention that, and then it's moving right. Again, point to point, so 1, 2, 3, 4, 5, 6 units to the right. And if you have 2 sentences along those lines that mention these 2 things, you're going to be in good shape.